Start it's 9:30. Okay, let's start. Okay, today we are going to have one session on introduction to heat exchanger, perspective of a mechanical engineer, and this is basically at the refinery lah. Okay, I put here perspective of mechanical engineer. So we want to see from the perspective of mechanical, such as the tip sheet, the tip sheet joint, the channel, the bonnet. Okay. So anybody, if you have any question, you can type at the chat. But if you can just unmute yourself. Unmute yourself. Ni ada pun juga. You can unmute yourself and you can straight away ask lah. It's easier that way. Okay, let's start. Okay, this is just to tell you, for Engineers Digest, this is our focus for 2025. Shell and tube heat exchanger. Okay, we will have a few series on this, especially on tema code and UHX as well. And then we will move to pressure vessel. Okay, view of this class on pressure vessel. Then we move to storage tank, and then we'll move to pressure safety valve. This is the plan for this year. It could spill over to next year, but we'll try to complete it by this year. Let's see. Okay, the scope for today. We want. Yeah, terus beres.
Full screen.
Full screen. Okay. Full screen. Okay. Okay. Okay, boleh. Nampak? Sekejap. Belum. Okay. Sekejap lagi. Share. Screen. Okay, boleh.
Okay, right.
Okay, Chun. Okay. So, yeah. Okay, so for today's session, we want to cover this. What is the difference between code and standard? And is tema a code or a standard? And then we want to cover what is heat exchanger from the viewpoint of a mechanical engineer. Then what are the type of heat exchanger in a refinery? This will be our main focus today. The type of the main focus will be the fourth one. This is the type. What are the classification of heat exchanger as per tema? Okay, next slide. Okay, difference between code and standard. Okay. Alright, what is tema? Tema stands for Tubular Exchanger Manufacturers Association. So from the name, you know that this comes from the word manufacturer association. So most of the standard is also governed by the manufacturer. Okay, is it a standard or a code? Okay, tema is a standard. Tema is a standard and not a code. Okay, what is the implication if it's a standard or is it a code? The implication is if it's just a standard, it is not a legal document, but it is widely recognized and followed in the industry. It is the same as piping SME B16.5. That is a standard where you have a nominal size of the pipe, what is the schedule, what is the size of the pipe, and that is a standard. It is widely followed. Why do we want to have a standard? Because it is easier if everybody is using the same standard, so there is no deviation in terms of sizing, in terms of thickness, because they are all using the same standard. But it doesn't have a legal implication. Okay, so what is inside tema? Tema provide guideline for design, fabrication, inspection of shell and tube heat exchanger. This one we will go in further detail in our subsequent class. We will go in detail with tema. Today is the introduction. Okay, number 4. What is the difference between a code and a standard? Code is a legal document that is enforced by law. For example, in heat exchanger also, there is another code that governs the thickness, governs the fabrication as well. This is SME 8 Division 1. And SME 8 is actually a code. So it needs to be followed. It's a code. So the designer and fabricator are liable for any accident or issue with the design or fabrication if it's a code. The responsibility is assigned to each stage from material design to installation. Okay, a standard is a guideline application like flange standardization. This is, as I said earlier, same like B16.5. Okay. Okay, what is inside tema? What is inside tema? We have 10 section and one non-mandatory appendix. Okay, section 1 is nomenclature. Will be our next class. We want to understand the nomenclature. And then there is fabrication tolerance. So if everybody is using the same standard, we have the same tolerance, fabrication tolerance. Okay. Then we have general fabrication and performance information, installation, operation, and maintenance. Okay, the one that we want to dive deeper from the perspective of mechanical engineer is actually section 5. This is RCB. What is R, what is C, what is B? We'll take a look at the next slide. But this is the one that we want to focus on. It's the mechanical standard tema class, RCB heat exchangers. I put this in white color. We want to focus this very detailed here and also in the upcoming class. Then we have section 6 for flow-induced vibration. For flow-induced vibration calculation, this is usually done by analysis, vibration analysis. Then this would determine the distance between baffle to baffle. Okay, and then we have section 7, thermal relation, section 8, section 9, section 10, recommended good practice. And we have one non-mandatory appendix. This is the tube sheet design, calculation and detailing. Why does it say here as non-mandatory appendix? Because if our heat exchanger is governed by SME 8 Division 1, the calculation for tube sheet thickness calculation is governed by SME code and not governed by tema. Okay, if our heat exchanger is not governed by SME 8, then the tube sheet design thickness is governed by this code, Appendix A. Okay. Alright. Why is tema important? Okay, this one I said earlier. It provides guideline for every function, starting from material selection, material design, fabrication, construction, and installation. Okay, it's important that the whole world is using tema, so we have standardization. Okay, this picture here, this is a floating type heat exchanger, which we will go a bit deeper after this slide. So far, it's okay. If you have any question, just unmute yourself, and then you can ask. If I can answer, we'll answer straight away. Okay, what is a heat exchanger? From mechanical point of view, not from a process point of view, so we'll make this simple. It is a static equipment, all right? Static equipment that is used to transfer heat between two fluid. One will be on the shell side and one will be on the tube side. With the intention of changing the temperature of the fluid. So if one is coming in hot, when it goes through the shell, through the tube, when it goes out, it will change the temperature from hot to cold. From the shell side is the same. Once it's coming here hot, then it will go cold. Or if it's coming cold, it will go out as hot. There is no rotary part. That's why this is a static equipment. Okay, it is designed to maximize heat transfer by using baffles. So we'll go into detail what is a baffle, what it is used for. Baffle is very important. And the most common type of the most common type in the world for heat exchanger is actually shell and tube heat exchanger. That is why we want to go. That is why we want to go a bit deeper on shell and tube heat exchanger. There are others heat exchanger out there. I think after shell and tube heat exchanger, it will be air fin cooler, widely used. And then there is plate type. We'll take a look at the other type of heat exchanger after this. But the most common is shell and tube. So you want to know very well on the shell and tube heat exchanger. Okay, STHC shell and tube heat exchanger consists of tube bundle, and inside the cylindrical shell. We'll discuss this further. The tube. Okay. The tube side fluid flow through the tube, while the shell side fluid flow over the outside of the tube. The tube is very important. From the tube side, it goes inside the tube, but from the shell side, it goes on the outer side of the tube. We'll check this after this. Baffles are used to divert the fluid flow and increase heat transfer. Okay, other types of heat exchanger includes double pipe, plate type, air coolers, and electrical heaters. Okay, you see this picture? What is this? This is actually a hairpin heat exchanger. If you know a fixed type heat exchanger, this is basically like a fixed type heat exchanger, but bent. It's similar like that. There is two pipe here. So why do we bend here? This difference in geometry, when we have a bend, it can cater better on the thermal expansion. This bend is very important. Okay, so hairpin heat exchanger, also known as a double pipe heat exchanger. Why is it called a hairpin? Because it looks like a hairpin. Okay, it's similar to shell and tube, but it's compact in design. Consists of two pipes. One is external, one is internal. Bend to U-shape to form a hairpin configuration. So this U-shape, as I said earlier, this U-shape is very important because it gives the characteristic of it can cater thermal expansion. Okay. The internal pipe carries the fluid to be heated or cooled. The external pipe carries the fluid used for heating or cooling. So there is internal and external pipe here. It is ideal for high pressure and high temperature application with low flow rate. Okay. So why are we not using this? Because it caters for low flow rate. That is the limitation for hairpin heat exchanger. For high flow application, we require shell and tube heat exchanger. Okay. You look at this picture, what is this? This is a heat exchanger as well. You look this, what is this? This is a plate. So this is a plate type heat exchanger. Okay. Alright. This consists of two end plate. Two end plates, this blue color, this plate, and the other end, this is two end plate. And in between, you have a lot of plate. Okay. Okay. With small thickness, very thin. Because it is very thin, okay, and because we require mechanical strength, the material will be a high grade material. The cold and hot fluid flow on either side. The cold and hot fluid flow on either side of the plate, with the plate acting as medium for heat transfer. Okay, you can see here. Later we'll look at this working principle. So main advantage is compactness. Okay, if the same shell and tube heat exchanger were to be used, shell and tube heat exchanger will be much larger, maybe about 60% larger than this plate type heat exchanger. So why do we use this? Because of its compactness. We want to save space. So it is used like in offshore application, where space is very hard to come by. So we like this compactness. Okay. So main advantage are compactness and heat transfer efficiency. Disadvantage is high pressure drop and fouling. We cannot have too much fouling here because once we are fouling, one fouling, then the flow will not flow. Later I will show the working principle. You can see better. Okay, so it is used for clean service. This typical application for clean service. So let's look at the working principle. Okay, done. Okay. Okay, start again. Okay. All right. See all the plates. Okay, this is hot water. Okay, just pause here a bit. So this is the hot fluid coming in. This is a gasket. You can see this is a gasket and this is also a gasket. So it's a double gasket here. Why do we have this gasket? Because if we do not have this gasket, this hot fluid will flow to this side also. So we want to direct the flow hot to this side only. Okay, that is the reason for the gasket. So this gasket is very important. If you have a broken gasket, then it will mix, and the efficiency of the thermal will be affected. Okay, let's go. Let's continue. Okay. Okay, so this is on the other side. So from the other side, you can see also, it goes from here. Okay, So from the the other side of the plate, the back side will be the hot one. The other side will be the cold one. So this cold one, you can see it is directed upward, and it will not mix with the hot flow here because of this gasket. So this gasket condition is very important. You cannot have a broken gasket. That is why it is recommended once we do this maintenance activity for this type of heat exchanger plate type, this gasket is required to be new one. We need to procure new because we cannot have a broken gasket. If not, it will mix. Okay. So this is the working principle. Fairly easy, but require a clean service. So that is the basically disadvantage. Okay, that is plate type. Then the other one, okay, this window. Okay, so the next, I would say the next widely used heat exchanger after shell and tube heat exchanger is actually this effin coolers. Okay, let's look at effin coolers. Okay, like shell and tube heat exchanger, you require two fluids. One is hot, one is cold. Coming in, interact with each other, then we have heat exchange. For effin cooler, you require air only. Okay, then you put a motor or a fan, either below or above. Okay, so air is used as medium for cooling. Okay, it consists of two headers connected by nozzle with lots of tubes in between. We will look at the working principle after this. Okay, the fluid flow in from one header and out the other. Okay, cooling is achieved by air flowing through the tubes by fan. So if you have a fan below here, we'll call this as a force type effin cooler. What is it? What does it mean by force? Force, it means that this air is forced to go from below here to above. This is force type. If you have this fan above, then this is called an induced type. Basically, typically what you can see in a refinery, we have this type of effin cooler. So it's a force type. Okay. So main advantage is using the surrounding air only. Air is free. You can use. Okay, and more cost effective than water cooling because you're using air. So main disadvantage are cooling rate is not as high as water because it depends on the surrounding ambient. Okay, at night time it will be cool around here, so it's better. At midday, around it will be hot, so the cooling rate might be lower. Okay, and the fin around the tube is easily damaged. The fin around the tube there will be a fin to help with the heat transfer, but it is easily damaged. Okay, let's look at the working principle. Okay, this fan, so this is force type, because the fan is below, so it's a force type fin cooler. Okay, you can see there's a partition. This is a partition at the header box. This is called a header box. So you have a hot plate coming in on the first half of the header box, going through the tube. Once it goes through the tube, whatever length it was, you have a fan below here. And when you have a fan below here, you are forcing the air to go through, then you are actually cooling this fluid. Okay, then it goes outside as cooler. Okay. Okay, so that is the working principle of air cooler. Okay, the other type of heat exchanger. Okay, the other type of having cooler is this. What is this? This is electrical heat cooler, heat exchanger. Okay, electrical heat exchanger. Why we use this? Basically, we use this to change the viscosity of the fluid. Because certain fluid, when it is cold, the viscosity is high, so it's not easy to move. So if you have this type of electrical heat exchanger, it will give heat, and the viscosity will be lower than for ease of flow. Okay, it's not much, but it's there. So this type of heat exchanger. Okay, so far, is there any question? Okay, so far okay. Okay, so we look at shell and tube heat exchanger. This is the most widely used heat exchanger. Okay. We want to go deeper, yeah. Okay, three main type of shell and tube exchanger. You have the fixed type, you have the floating type, and you have the U-tube type. Okay, with advantage and disadvantages. Okay. Okay, what does it mean by a fixed type? On your left here, hold the pointer. Focus. Okay, so on your left, this is fixed type. Tip sheet that is directly welded to the shell. Okay, this is very important characteristic of fixed type. Okay, this is integral. We can call it integral. Integral means that the tip sheet that is directly welded to the shell. You look at the picture after this. This tip sheet is directly welded to the shell. Okay, floating type. Okay, floating type is the tip sheet that is not fixed to the shell, allowing expansion and contraction. This rear end, later we will see, this is a rear end. Okay, you can see this is a floating type design. We'll go in detail after this. This is a floating type design. And this floating type design, when you have a thermal expansion, this floating type design will be able to move. Will be able to expand and will be able to contract. So this caters a lot of the thermal expansion issue because of the floating type design. Okay, on the U-tube, you can see this tube is bent like a U. That is where the name comes from. This tube is bent, so this is a U-tube design. This bending, okay, similar like hairpin. Can remember the hairpin, there is a bend. So this bending, because of this difference in geometry, it can cater thermal expansion as well. The only issue with this is it's difficult to clean. Okay, what is the difference between U-tube and other type of heat exchanger? Is also the number of tip sheet. You see the tip sheet is only one. The other having two tip sheet, different sizes for floating. This is a bigger size tip sheet. This is small size tip sheet. This is same size tip sheet. This having only one tip sheet. Oh, okay. This is having only one tip sheet. The other doesn't have a tip sheet. Okay. Okay, nomenclature in the next class. Nomenclature means that this is your front end, this is your shell, and this is your rear end. There is so many configuration for tema. This will be covered in the next class. Okay, alright. Classification by service. Okay, we have three types of classification and three types only. This is class R, class C, and class B. Okay, in refinery and petroleum, you will see so much is class R. Class R. This is for refinery and petroleum. Class C is for commercial service. Therefore, it has a different technical different. Later we look in tema for C, for B, and for R. There's a different. It is less stringent. We can say class C and class B is less stringent, less thickness required. We will see further. For class R, it is more stringent because this is for refinery and petroleum service. So later when we look at tema, you can see that there are RCB. RCB. If it's R, it is for class R. Sometimes it is said this clause is CB. CB means this is for class C and class B only. So don't take that into consideration if our heat exchanger is class R. It will go in detail. Okay, fixed type. Okay. This is a fixed type heat exchanger. The tube side element are the parts that comes in contact with the tube side. These are the channel. Okay, hold on. I will try to blow this one up first. And show. Okay. Okay, let's try this. Okay. Alright, this is a fixed type. There is two tube sheet here. There is two tube sheet here. This is the first tube sheet. This is the second tube sheet. It is integral to the shell. Integral to the shell. So it is welded here. Welded here. Integral to the shell. This is what you call a channel. And this is your bonnet. This is the nozzle. So this is the tube side. Tube side means that when your fluid is coming in this nozzle, okay, it will go along this tube length. It will go along this tube length. That's why we call it a tube side. Along this tube length, and it will go up and go back along this tube length again. Then it will exit. So you will notice that this nozzle, inlet and outlet, is at the same front end, front side of the heat exchanger. Okay. This is tube side coming in at elevated temperature. How is it get cooled? It's get cooled by the fluid that comes from the shell side. Okay, from the shell side. This is a baffle. We'll go into detail to this. This is the baffle. This is a baffle. Why do we have a baffle? Because we want to redirect the flow coming in from the shell side. Because once this fluid is coming in, it will go around this baffle. It will go around this baffle. Why do we need it to go around the baffle? Because of retention time. We do not want it to go straight away to outlet. If it goes like this, retention time is more, then the heat exchange is more. So that is what we want. So this is a fixed type. There is an issue with this fixed type. Okay, what is the issue for the fixed type heat exchanger? You see, this is a flange, this is a bolt. Once you open this bolt, you can drop this bonnet channel. You can drop this, and then you want to clean the tube. If you want to clean the tube, you can do so by using maybe a high pressure water jet going through this tube. You can clean this tube. Okay. For any fluid that is have higher fouling, we want to put it on the tube side. Because why? If fouling occurs, we can clean it on the tube side. But the issue with this fixed type heat exchanger is we cannot access the shell. Okay, because it is already integral with the shell, meaning that you have already welded this tube sheet to the shell. You have welded this. So if you have welded this, you cannot reach inside the shell. Therefore, the shell side you cannot clean. That is why if you want to choose this type of fixed heat exchanger on the shell side, make sure it is a clean service. But it's difficult. Sometimes operation have upset. Okay. Initial kecil adik. Okay. Okay, try to understand. Tube side element are the part that comes in contact with tube side. These are channel, nozzle, inlet, and flange. Whatever fluid coming in at the tube side below here, whatever fluid coming in at the tube side, going to the flange, going to the channel, going to this tube, touching this pass partition, this is all we call a tube side element. Okay, shell side element are component that comes in contact with the shell side fluid. What does it mean? This nozzle, when you have a fluid coming here, this is on the shell side. If this fluid is in contact with whatever is inside here, we'll call that a shell side element. This will be the nozzle. Okay, the baffle, as I explained here, the baffle, the tie rod. We have a tie rod, sealing strip, spacer, and rod. These are all considered as shell side element. Why is it a shell side element? Because when the fluid coming in at the shell side, it touch all these elements. That's why it is a shell side element.
Tuan Syed,
Yeah.
I guess it's really good that Fatima highlight in the chat box on the
Okay.
buffer plate,
Uh,
whereby she mentioned that the buffer plate function to have a turbulent flow rather than we have a laminar flow. It's a really good point to
okay.
be highlighted.
Okay. Thank you. Thank you, Fatima. Okay. Yes. Agree. Especially from, yeah. Okay. Thank you, Fatima. Okay. Just okay. The partition plate separate the two fluid in the heat exchanger. So we have a partition plate. It is there to separate the fluid. Okay. If it presents on the tube side, then it is a tube side element. If it is present on the shell side, it becomes a shell side element. What does it mean? So this is a partition plate. This is a tube coming in, fluid coming in on the tube side. This is a partition plate. We call this a tube side element because it is at the tube side. So in heat exchanger, we have something that is called as uh, a partition plate or a longitudinal baffle, I believe. That one will be considered as a shell side. Okay. The two tube sheet are direct. Okay. The two tube sheet are directly welded to the shell. As I said earlier, this tube sheet is directly welded to the shell, both sides. Okay. The tube sheet are extended as flange so that it can be bolted with the channel side flange. So you see, this is a tube sheet and it is extended also so that this flange we can bolt it. Okay, and the tips are connected to the tip sheet. Okay. Okay, this is a floating type. Okay. 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 So I will try to make this picture use on bigger so that we can see. Okay. Alright, let's see. Okay, this is tube side fluid inlet at elevated temperature coming in. You can see this is not a bonnet type anymore because we have a channel cover. This is a channel cover. Why do we want to have a channel cover? Because we want to be able to clean this tube so that we can open. So this is a channel cover. So this is tube side coming in, going through the tube, going to the tube. Okay, going through the tube. And then this is a floating head. We'll go back below here. We will go into the tube again and then it will exit. This is a partition plate. This is a tip sheet. You can see the tip sheet it is different from the fixed side, fixed type. This tip sheet is in between the two flange. Okay. And then we have a floating type design here. This is called as this is A, this is X, this is S. Later, next class, we'll go to the nomenclature. So S, the rear end is S. S is a floating type. Why do we want to have this floating type? To cater any thermal expansion. If we have a high thermal expansion, this floating side, it will go to the right slightly, exaggerating, but it will go to the right, and then it will contract back again. So any thermal issue, it will be basically the floating side will be able to handle. And then it caters also issue from the fixed heat exchanger. The fixed exchanger uh, we cannot clean on the shell side, but for floating type we can clean the shell side. How do we want to clean? This is a backing device. This is a split flange. We can open this. You can see there is a two flange here with tip sheet in the middle. So this flange we can open, and this bolt we can open. Release this flange, and this whole uh, tip bundle can be removed, and then we can send it to the washing bay and clean. And then leaving this shell that we can clean as well, the internal, and also the external of the tip we can clean also. Okay. So, but notice this tip sheet is bigger. It's bigger than the rear end tip sheet. Notice that. Because why we want to notice this? Because if we want to do a shell's tip side hydro test, okay, this right side is require test ring. It requires a test ring. But later on, more on that later. This side will not require a test ring because it can be flange. It can be connected to the channel. Okay. Okay. Okay, so I've discussed the tube bundle can be removed by removing the split flange. There's a split flange here. Then removing the tube bundle for cleaning and washing bay. Okay. Okay, what is this? This is a U shape. Okay. Okay, all right. So, okay, this is a U tube. You can see the tube is bent. There's a requirement here. Later I will show this requirement in next class. Okay, but basically it is a U tube. So the difference in geometry makes it able to cater thermal expansion. So this is also can cater thermal expansion. This is a bonnet type. Okay, fluid comes in, goes through the tube, mix around and exits. It's the same. This shell side fluid comes in, and because there is a baffle, so it will go like zigzag for more retention time, and also to create turbulence, like Fatima said. Thank you. Okay, mechanical cleaning is difficult due to bend area. This area will be difficult. HWJ is used for mechanical cleaning from the tube side. Okay, so far, is there any question? Okay,
Hello,
so we,
Sansai.
okay, yeah, okay, yeah.
I wonder about a tube bundle.
Bundle,
If
okay.
um, if there's um, along the way, if the heat exchanger is already used for a long period of time, and
Uh,
then we inspect the tube bundle and there is a hole or defect, and how do we know the ability or percentage can we use the
okay,
exchanger before we completely cannot use it anymore?
okay,
Understand?
understand. I
And how do
understand.
we expect what kind of method that we have to inspect, and how long percentage is acceptable?
Okay, thank
Uh,
you. Thank you for the question. So I think the answer will be twofold. One is from the mechanical side, one is from the process side, and one also from the design side. So from the design side, initially, typically, we will have 10% more tube, 10% more tube than what is required. Let's say that we have 1,000 tube, 1,000 tube. So if we design this to have a 10% margin more, so we can have about 100 tube that can be plugged. We can plug it. It can be plugged both end, uh, and this will not cause any issue with the heat duty. Okay, that 10%. However, we need to consult the process team, or PED, because this the process team they can either run a simulation, or they can check, through the pi trending. The pi trending meaning that they will be able to monitor what is the temperature outlet, what is the temperature inlet, the delta T, and then they will make some calculation, and then they will say whether the heat duty is still okay or not. Okay, and then from the simulation, either by Aspen or by HTRI, they will know uh, if if we plug so many tubes, what is the effect or future effect to the heat duty of the heat exchanger. Okay, so number one, I say that there is 10% margin, we can use that. But number two, we still need to get advice from the PED or process side. We will be able to check the outlet temperature and do calculation from there. And the third question is, how do we know whether this tube is okay or not? Okay, inspection will still required. So typical inspection we can do is more detail on this on later class. But the inspection we can use is called RFET, RFET, or IRIS. IRIS. So what does this inspection tells us? This inspection tells us what is the available thickness, or what is the tube loss or thickness loss of the tube. Okay, if the tube has already seen a general corrosion or a corrosion, let's say that the thickness has lost 10%, it's still okay. We will still use it. But general rule of thumb, if it's more than 40% thickness loss, then usually what we do is we will plug the tube lah, if it's more than 40%. So inspection required either by iris or RFED, and we will see the result. If the result is more than 40% wall loss, we will plug the tube. And then depending on how many tube that we need to plug, we will check on the design margin of 10%, or we will check also with PED. If the number of plug that we need to make will affect the heat duty. If it affects the heat duty, then we require a permanent solution for this. Okay, permanent solution for this could be to order one more tube bundle. Okay, is that answering the question?
Okay, thank you. So basically, we have to check the limitation 10% margin, and then seek the advice from PED, and also we need to do the visual inspection lah, iris and yes. Okay, thank you.
Okay, iris and RFED, there is a device lah. It's a device.
A device.
It goes inside the tube along the tube length. Then along the tube length, and then there is from there they will know what is the wall loss lah of the tube. Okay, later we'll have that class on RFED and iris. Okay, thank you. All right, so okay, this is number of passes. The number of tube in each passer shall be equal to ensure fluid flow is evenly distributed so that heat transfer is efficient. But what does it mean by number of passes? Okay, consider this. This is what we call as a one pass. What does it mean by one pass? This is a front head, no partition because it's one pass. When the fluid enters, when the fluid enters from the tube side, it goes along the tube, then it exits. It will not go back again. So you can see this picture here. This picture here, this is on this front side. This is on this rear. You can see there is no partition plate at all because it is one pass. It goes down, it exits. So fluid flows from one side to other in a single pass. Flows the tube only once and exit the shell. Okay, this is one pass. So what does it mean by? Yeah. Ada nanti ni tak tengok. Tengok dia tu. Aeroplane block. Okay, this is two pass. What does it mean by two pass? Two pass means that this fluid enters the bonnet on the tube side. It goes to the tube, goes to the rear end, it goes back again, and it goes out. So you'll see that there is one pass partition, one partition here, one pass partition here. This is two pass. Okay, partition plate is used, allowing for two pass arrangement. The tube sheet is divided into two parts. This tube sheet, okay, two parts. Okay, you can see a groove here. There will be a groove here along this length of the partition plate. Okay, all right. So this is two pass. Okay, this is four pass. What does it mean by four pass? So this is on your front. This is on your rear. Okay, tube sheet is divided into four sections. Okay, tube sheet is divided into four sections with two partition plate. Okay, this is entering the tube side entering. Okay, then it will go along the tube. It goes to the rear. From the rear, it goes to this side, and then it goes back again to this front side. Second. Then from the second, it goes down. On the third, it goes along the tube, goes to this third one. From the third one, it goes to the fourth, and then it goes along the tube, and then it goes to the fourth. Okay, so this is divided into 4 sections. This is what we call a 4 pass. So it goes through the tube 4 times. Basically, it goes through the tube 4 times. But you can see this partition plate, how many partition plates? 2. If it is, if it has 4 pass, the partition plate is 2. You just divide by 2 this one. Okay. Okay, let's see here, 6 pass. What does it mean by 6 pass? So if it's a 6 pass, partition plate is 3. So you divide by 2 only. So it's 1, 2, 3 partition plate. What does it mean by 6 pass? It goes around the tube 6 times. So first time it goes, then this from this side, it goes, then to the rear, it goes to the second one here. It goes to the second one here. Then from the second one, it goes back to the front here. Then goes to the third, exit the third, then third go to the fourth, and then it goes to exit the fourth, fourth go to the fifth, fifth go to the sixth, and then it will exit the heat exchanger. So it goes around the tube 6 times. This is what it means by 6 pass. Okay. 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 Any question on the pass? Okay. So now we want to understand the parts in shell and tube heat exchanger. This one is a template. I forgot to change. Okay. Alright. Consider this. Yeah, okay. We have discussed already. What is this? This is a fixed type heat exchanger. How do we know it is a fixed type? You can see this is we have 2 tube sheet here, and this is integral to the shell. We have 2 on it. Okay, this is a fixed type. So channel cover, you can see this is a channel cover. This is channel cover. Okay, it holds the fluid that needs to be heated or cooled. Basically, whatever is coming from the tube side, it holds it. Then it will go along the tube. Shell, what is shell? This is shell side. This is the shell side. Okay, it is the outer part of the heat exchanger that holds the tube and the fluid used to heat or cool them. Okay, fixed tube sheet holds the tube in place. This is a fixed tube sheet integral to the shell, welded. So it holds the tube in place. The nozzle, you can see this is a nozzle from the tube side coming in. Then the nozzle from the shell side coming in, this is a nozzle. Vent and drain. You can have a vent connection and a drain connection. Why do we want this? To remove air or to remove water from the shell side. Expansion bellow to accommodate thermal expansion. So this is a expansion bellow. Why do we have an expansion bellow? Okay. Why do we have an expansion bellow on the fixed side? Because fixed side, one of the disadvantage of fixed side, if we do not have an expansion bellow, because this is already welded to the shell, it could not cater thermal expansion. Okay, because the thermal expansion is trying to go sideways. This tube is trying to push it sideways to the left and to the right, but it will not be able to push because this tube sheet is already welded to the shell. So fixed type is not good for thermal expansion. However, if we put an expansion bellow here, okay, then it could handle thermal expansion. But this expansion bellow will require maintenance activity. Alright. Later class we will have a calculation on this expansion bellow. Okay. Okay, internal part, impingement plate, tie rod, spacer, baffle support, partition plate, backing device. Impingement plate. Next slide we will have what is an impingement plate. So impingement plate basically is to protect the tube bundle from direct force caused by high fluid flow. Okay, because on this shell side, this fluid flow incoming could have a very high flow. Okay, if it has a very high flow, it could impact this tube. We want to reduce the impact. What do? We put a plate here, which is called a impingement plate. Okay, right, then we have a tie rod and we have a spacer. Tie rod and spacer is used like this between this baffle. We want to maintain this space, whatever space this is. We want to maintain this space, and this is maintained by a spacer. Okay. All right. Then we have a partition plate. This is a partition plate. Okay. Then we have a backing device. If we have a backing device, meaning it is a floating. Okay, this one is a backing device. Okay. 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 Okay, baffle is a device used to control the baffle. Baffle is a device used to control the flow of fluid. We discussed this one earlier. This is your baffle. So whatever fluid coming in will need to redirect its flow to go around the baffle. Okay. It's designed accommodate calculation to reduce this one I could be wrong too. Sorry. The baffle is held in place by thyroid and spacer. Okay. This is your thyroid and this is your spacer. Okay. Because of this spacer, this length between the baffle can be maintained. But sometimes they just weld this baffle to the thyroid. It's permissible also. Okay. Okay. So this picture you can see. Okay, this is a picture of the impingement plate on the tip side. Impingement plate. Okay. That is the end of the slide. The end of the introduction to shell and tip heat exchanger. Okay. Do we have any question on the chat box, or if you want to unmute yourself and ask? On a later series, we will have a class for nomenclature and for the section 5 as well. That one we will go, I think, in detail. This will cover the cladding on the tip sheet. What is the thickness required as per tema for the cladding, and also we will go for the non-mandatory appendix A, the thickness calculation. Then we will go through UHX on the tip sheet thickness as well. Okay.
Question Sir dalam
Yeah. Is it?
there is a question. I think 2 question
Okay.
in the chatting.
Oh, the question chatting. Okay. Okay. Please tell me internal, external part. Okay, internal, external. This is basically this question. Thank you for the question, Omar. This question is basically you know the shell and tube heat exchanger. You have the tube side and also the shell side. This would mean the same for the hairpin heat exchanger. One is internal side, one is external side. Internal being the fluid that is going to be cool or heated, and external is a different fluid coming in to assist on the heat exchange lah. Okay. Right. Okay, for the question. Baffle make the flow table. Okay, this one is earlier. Thank you. How to determine what kind of tip bundle require vibration support? This will be, I believe, will require a HTRI calculation. HTRI calculation. Require vibration support. Vibration support. Vibration support. Okay. This would mean that the distance between the baffle, and also we will have a vibration analysis. So from the vibration analysis, the result of the vibration analysis will say whether we could have a vibration issue or not. And also this correlate also on the baffle distance as well. If the baffle distance is too large, then the tube will be prone to vibration. So this distance between baffle to baffle is important, and this will be checked in the vibration analysis. Okay. Hope that answers the question. What's the pros and cons between fixed flow? Okay, all right. I try to answer this. Fixed type. Fixed type is a simple heat exchanger. It costs less, but that's a pro lah. It costs less. But the con or the disadvantage of using fixed type, we cannot clean on the shell side. There is no way uh, to enter the shell side. And also, if the delta T, if the thermal stress is high, meaning that the thermal expansion is high, it could basically break the tip sheet, because the tip sheet will be bent. Okay, the tube is trying to go further away, but the tube sheet is holding it. So if that's very high, you can have a failure on the tube to tube sheet joint. Okay, maintainability, basically floating type is the best one, because we can remove the tube bundle and clean the outside layer and inside layer of the tube, and also shell side also will be able to clean, and there is no issue like YouTube, that bend area, because on the internal part of that bend area you cannot it's very hard to reach. Okay, cost wise, floating will basically usually cost more. Floating will usually cost more than use YouTube and fixed type. Okay, clinic point of view, joint efficient or but possible to be one. Okay, this one I'll be to get back to you. 7 Brand. Okay, joint efficiency. Okay, let me get back to you. This one. Brand. Okay, common fault happen to heat exchange during plant running. Okay, there is a lot of common fault lah. I think one we can say, oh banyak lah common fault nak cakap ni. Okay, one case I think we discussed earlier on one case. There is a design issue. Design issue meaning that it didn't cater that all of the tube, the metal tube, the temperature of the metal tube should be higher than the dew point temperature. It was not catered during design stage. What happened was, since this is on the CDU line, whatever CDU condense, the first condensation is very acidic. Because of the basically failure in design, and we have a condensation on the tube, then we have water, and we have high salt, and we have hydrochloric acid at the outer side of the tube. What does it mean? It means that locally or general corrosion or local corrosion happen on the tube, and then it penetrates the tube, causing whatever fluid from the shell side entering the tube side, depending on which pressure is higher. So that is one. The other one could be a plant upset. Whatever plant upset is coming in, let's say you have a fixed type heat exchanger, you cannot clean the shell side, and the shell side is deemed to be clean during the design stage. But if you have any upset which is causing any shell side to be dirty, if it's dirty and you cannot access the shell side, what does it mean? It means that this tube will be foul. There is fouling on the tube side. If there is fouling on the tube side, the thermal efficiency of the heat exchanger or the heat duty will be less. So the temperature outlet coming out, that temperature expectation is less, then this could cause upset to the downstream equipment, whether it's going to reactor or wherever. Okay. Then maintenance issue is there as well. Maintenance issue, let's say we have a floating type. You see there was a backing ring, or backing flange. That rear end, you need to open it, and then maintenance issue could be that there is a partition plate. Once you want to close back the partition plate, this partition plate is not aligned. Maybe they put it wrongly. So it is rotated one bolt. It is rotated one bolt. So what would happen? This partition plate will press all of the tube. Once it is pressed the tube, this tube has a bit of extension, like 3 mm like that. So once it is pressed, all this tube will be pressed, and then what we did, we need to plug all of that for nothing actually. Okay, I think that is 3 of the common fault. Could be more, and it will be more. These three I can share right now. Any other question? Izzat ada soalan Izzat? Izzat ada? Okay. Any other question that? On the HTRI, maybe we can have later if it is agreed. We'll check. Maybe we can have one more HTRI session because it is quite related to this. Not quite, very related to this sharing activity exchanger. Maybe we can answer more on the vibration side now. Okay. Okay. So let's try one more time. Is there any other question? Something not clear? This slide I will share with you. This slide I will share with you, and also this recording also I will share with you as well. Okay. Okay. So if there is no more question, we can adjourn this class, and we can see you on the next class on nomenclature. Okay. Oh, thanks. Okay, thanks, Izzat. Thank you all. Okay. Okay, thank you. See you in the next class. Thank you.